In the last video, we have seen the algorithm insertion sort. We took the random data and we have seen how insertion sort sorted it in increasing order. Now let's do the analysis of that same algorithm. In that algorithm, we have total 7 lines. First of all, the thing we need to see for analysis is that it is an iterative algorithm. You see, there are 2 loops and there is no recursion. For iterative algorithm, the analysis is simple. We simply count that which line is executing how many number of times, because ultimately we are just seeing in the analysis that how many number of instructions are executing. So let's start counting them. The first instruction for j is equal to 2 to n will be executed n times. Why n times n, not n minus 1 times? Because for 2 to n it is total n minus 1 times, it will be true. And finally, when j will become n plus 1, that is 1 time, which will be false. So total it is n times. Then the second instruction, it is inside the loop, so it will be executed n minus 1 time, because when this condition, loop condition will be false, this instruction will not be executed. The third statement has also the same status, so it will also be executed n minus 1 times. Fourth statement. Now here comes the technical part. This is technical because this instruction basically depends upon the type of input. For different input, sometimes this instruction will be true, and for some different input, sometimes this instruction will be false. So let's do first for worst case. So what's our worst case mostly is if the data is sorted but in decreasing order. So let's say 7, 5, 3, it is 2, it is 1. The worst case of insertion sort if the data is sorted in reverse order, because it becomes worst case because we intend to sort it in increasing order, and for every time this instruction will be true. You see, 5 is smaller than 7, 3 is also smaller than both these values, 2 is also smaller than all of these values, and 1 is smaller than all of these values. So that's why this instruction will execute maximum number of times. So let's see how many number of times. So first time it will be executed 2 times. How 2 times? First 5 will be compared with 7, and then it will check previous element. I will become minus 1, but the instruction will execute it 2 times. 1 time it will be true, 1 time it will be false. For 3, it will be executed 3 times. Again, 2 times it will be true, when 3 will be compared with 5 and 7. And finally, when I will become minus 1, it will check the third time when the instruction will be false. So for 4, it is 4, and for 5, it is 5. So how many times in general? So the series is moving from 2 plus 3 plus 4 plus 5 up to where? N. Why? Because the last value of j will be n. So we can find the sum of this series because we know that sum of first and natural numbers is n into n plus 1 divided by 2. So it will be equal to n into n plus 1 divided by 2 minus 1. Why minus 1? Because we are not adding 1 here. So in worst case, this instruction will be executed n into n plus 1 divided by 2 minus 1. So we let's call it as worst case. What about best case? The best case is opposite to that one, that the data is already sorted in increasing order. So it is 1, 2, 3, So if the data is already sorted in increasing order, every time this instruction will become false the very first time. Why? Because every time a of I plus 1 will not be less than a of I. So every time this instruction will execute only one time. So j is equal to 2 one time, so j is equal to 3 one time, so j is equal to 4 one time, so j is equal to 5 one time. So what will be the series? 1 plus 1 plus 1 plus 1 up to so on. And how many times there will be 1? And minus 1 times. Because the outer loop is running through and minus 1 times. So this instruction will execute n minus 1 times in the best case. First complete the analysis for the worst case and best case, then we will see what will happen in the average case. So we know that the inner statement which are in a particular loop will execute one less time. So it will be n into n plus 1 divided by 2 minus 2. And for best case will become n minus 2. Same, this will also be executed n into n plus 1 divided by 2 minus 2, and this will be executed n minus 2 times. And what about the last instruction? This instruction is inside the for loop, but it is outside the while loop. So it will also have the same status, that is for instruction number 2 and 3. So it all will also be executed n minus 1 times. Okay, first do it for the best case, then for the worst case, and then we will do it for the average case. So let's count them. For best case, a of n will be equal to n plus n minus 1 plus n minus 1 plus n minus 1 plus n minus 2 and plus n minus 2, and finally n minus 1. So you can see that all the terms are either constant or n terms. So what is the highest order term? It is n. So we can say it is theta of n. Then for worst case, it is t of n is equal to n plus n minus 1 plus n minus 1 plus n into n plus 1 divided by 2 minus 1 plus this term is appearing 2 times. So 2 into n plus 1 divided by 2 minus 2 n plus n minus 1. So you can see the highest order term is n square here, because when this n will be multiplied with this n and this n will be multiplied by this n, so both will become n square. So what is the highest order term? N square. Okay, one last case is the average case. Now average case is important because 99% of the times we fall in average case. Best case and worst case occurs only 1% of the time. Okay, now what is the intuition for the average case? Intuition for the average case is that these are the 3 instructions which are separating the 3 cases. So we know the average case will be the average number of times this instruction will execute. So if this is the minimum number of times this instruction is executing and this is the maximum number of times, then what will be the average? Add them both and divide by 2. So let's do it. So n into n plus 1 divided by 2 minus 1 plus n minus 1 divided by 2. Now, without solving it completely, you can see that there is still appearing a n squared term. Though it will be divided by 2 and then again with 2, maybe with 4, but still it will be n squared. If n squared divided by 4, it will still be a highest order term n squared. So if the highest order term is n squared, then for average case it is also theta of n squared. So only in the best case it is better than selection sort and inverse sort, but it is same for average case and worst case still theta of n